Hello everyone, welcome back to the lecture series on business mathematics. So, in this third lecture, before moving further, let us quickly recall what we discussed in the last lecture. As you know that in the last lecture, we derived the formula to find out the sum of first n terms of an arithmetic progression. So, let us quickly recall what do we mean by an arithmetic progression first. So arithmetic progression is a progression in which the difference between any two consecutive terms remains same, right? So this was about arithmetic progression and we discussed that the formula to find out sum of first n terms of an arithmetic progression is given by this. Sn is equal to n by 2. Sn is equal to n by 2 twice a plus n minus 1 d, where what is a? A is the first term of given progression and D is the consecutive difference, right? So we know that if we are having the first term and the value of consecutive difference, then we can easily find out the sum of first n terms. We rewrite the formula as Sn is equal to n by 2 a plus L, where a is the again first term and L is the nth term or last term. That means suppose you are asked to find out sum of first 10 terms, then in that case L will be the 10th term of that particular arithmetic progression. So using these two formulas we can easily find out the sum of first n terms of an arithmetic progression, right? We discussed several examples related to this. We discussed how to find out sum of first n terms, and we also discussed an example in which we were given the value of sum of first n terms of an arithmetic progression and we were asked to find out the first four terms of that particular arithmetic progression. So we discussed these two examples in last lecture. Let us see some more examples. So let us see the question first of all. Given an arithmetic progression with the first term a1 equal to 10 and the eighth term a8 is equal to 70, right? So we are given the values of two terms, first and eighth term. Now the question is calculate the sum of first eight terms. Calculate the sum of first eight terms. Now we know that we are having two formulas to find out the sum of first n terms of arithmetic progression. So the first formula is Sn equal to n by 2 twice a plus n minus 1d, and another formula is n by 2 a plus L. So a is the first term, L is the n term. So we can observe that using the second formula will be more easier. So we'll use the second formula. So here we have a1 is equal to 10 and a8 is equal to 70. Now the question is find the sum of first n terms. That means n is equal to 8 in this case. N is equal to 8 in this case, right? So let us see how to find out the sum of first n term. Sn is equal to n by 2 first term plus last term or eighth term. Let's put the values. What is n? N is equal to 8. 8 by 2. A1 and A8. A1 is nothing but the It is 10. A1 is equal to 10 plus 70. Let us simplify. 70 plus 10, that is 80, and 8 by 2, that is 4. So therefore Sn is equal to 320, right? Sn is equal to 320. So this is the sum of first n terms of an arithmetic progression whose first term is 10 and the eighth term is 70. So this was very much simple example, right? Finding out the sum of first n terms in which we were given two different terms, first one and last one. So the formula is very much easy. N by 2, first term plus last term. Let us see one more example. So give an arithmetic progression, give an arithmetic progression with the first term to be 2 and the consecutive difference to be 3. Also the sum, calculate the sum of first 10 terms. Calculate the sum of first 10 terms. Okay, again, very much simple. We are given there the first term to be 2, right? So we are having the value of A. Consecutive difference to be 3. That means the value of D to be 3. And sum of first 10 terms, so N is equal to 10 in this case. So here N equal to 10, A is equal to 2, and the consecutive difference, that is D equal to 3. So again, let us see the formula. The formula is N by 2 twice A plus N minus 1 D. So we'll use the first formula in this case. So Sn is equal to N by 2 twice A plus N minus 1 D. Let us put the values. N by 2, N by 2. So N is equal to 10 divided by 2 twice A. 2 into A, that is 2 into 2, plus N minus 1, that is 10 minus 1, into D. D equal to 3 in this case. We are given that D is equal to 3. So 10 minus 1 multiply with 3. Let us simplify. 10 by 2, that is 5. 2 into 2, that is 4, plus 10 minus 1, that is 9. 9 into 3, that is 27. So this is equal to 5 multiply with 31. 5 multiply with 31. So this is equal to 155. So this is the sum of first 10 terms of an arithmetic progression with the first term to be 2 and the consecutive difference to be 3. Right? So these two were very much simple examples of arithmetic progression. Let us see one more example. So for that, let A and B be given positive real numbers. Right? A and B are positive real numbers. Now we have to show that the sequence log A, log a square upon b, log a cube upon b square, and so on is an arithmetic progression. Also calculate its general term, right? So see here we are given a sequence log a, log a square upon b, log a cube upon b square, and so on. So you can observe that in the first term the power of a is 1 and power of b is 0 because a upon b raised to 0, something raised to 0, that is 1. Log a square upon b. So in second term power of a is 2 and power of b is 1. In third term power of a is 3, power of b is 2, and so on. Right? So first we note down the general form and we'll see that this sequence is an arithmetic progression. Now to show that this is an arithmetic progression, what we have to do? We have to find out the consecutive difference. That means if the difference between any two consecutive terms remains same, then it is an arithmetic progression. So for that, and one more thing, see here we are given that a and b are positive real numbers. Now the question is that why they have considered positive real numbers only, right? So this is a question for you. Why we have to consider only positive real numbers for this sequence? Okay. So we can observe that we can observe that the nth term of given sequence is what it should be. The log is common. In first term power of a is 1 and power of b is 0. In second term power of a is 2, power of b is 1. In third term power of a is 3 and power of b is 2. So what will be the power of a in nth term? Obviously it will be a raised to n. And what is the power of b? Here power of a is 1 and power of b is 0. Power of a is 2 here and power of b is 1. Power of a is 3, power of b is 2. So it will be n minus 1, right? So the general term is log a raised to n upon b raised to n minus 1. So this is our a. Okay. Now let us find out the consecutive difference. So now log a square upon b minus log a upon 1, right? So this is equal to log a square upon b multiply with 1 upon a. Why? Why? Because we know that log a minus b is equal to log a upon b, right? Log a minus b is equal to log a upon b. So log a minus b, we know that log a upon b is equal to log a minus log b. Okay. So here log a minus log b is equal to log a upon b. So a square upon b upon a. So this is nothing but the log a square upon ab, right? So this is what we have written here. Okay. So this is equal to log a square upon ab, and we can observe that this one a is cancelled out. So it is simply log a upon b. That means the difference between second term and first term is log a upon b. Similarly, now let us see the difference between third term and second term. A cube upon b square minus log a square upon b. Again log a minus b is equal to log a upon b. So it is log A, that is A cube upon B square upon B. So it is multiply with B upon A square. You can observe that this power of B is cancelled out. A square and A cube is cancelled out, right? A square and A cube is cancelled out. So what is remaining? Only log A upon B, right? In general, in general, log, what is the nth term? You just mentioned the nth term. It is A raised to n, B raised to n minus 1. So A raised to n upon B raised to n minus 1. This is our nth term, minus log of A raised to n minus 1, B raised to n minus 2. This is our n minus 1th term. So this is equal to log A raised to n, B raised to n minus 1 upon this term. So upon this term, that means multiply with B raised to n minus 2, A raised to n minus 1. Right, now you can observe that this n minus 2, n minus 2 power is cancelled out, n minus 1, n minus 1 power is cancelled out. So we simply log A upon B. Therefore, the consecutive difference for any two terms is log A upon B. Now we know that if the consecutive difference between any two terms remains same, then that sequence must be an arithmetic progression. Therefore, given progression is an arithmetic progression, and this is your answer. Very much simple example is that. Okay, so I think this is enough for today. We'll continue discussing on various progressions in next lecture. Thank you.